Which one of these elements have the highest and lowest second ionization energy? Second ionization means that the atom at hand has lost its electrons twice. So instead of writing Na2 and then Na+, I just wrote what their electron configurations would be. So because sodium is here, you lose one electron, so that gives you a neon configuration. Neon losing one electron gives you a fluorine configuration. So that's why I wrote neon and fluorine, and the same example for the rest. Now, neon going from fluorine, because we're looking at the second ionization energy, neon going from fluorine is a noble gas going to lose an electron. That means it's going to take a lot of ionization energy. It needs a lot of energy to do that. Lithium, next example, lithium going to helium is an alkaline going to a noble gas, which is very easy. So it will be a low ionization energy. And helium going to hydrogen is a noble gas going to lose one electron, and that has a very high ionization energy. But which one, sodium or lithium? Which one's going to give us a higher ionization energy? Well, this is a part where you want to make this statement in your exam to show off your knowledge. So you're going to say, the smaller the size, and we know top right has small size, smaller the size will increase Z effective. And this is because small size means nucleus is closer. So it will increase nuclear attraction. And so increased nuclear attraction increases Z effective. So increasing Z effective increases ionization energy. So to summarize, if you have a small atom, your nucleus is going to have a stronger pull on the electrons, which increases Z effective, and also increases the amount of energy needed to remove that electron, which is being tightly held. So that's a statement you're going to make. Therefore, helium going to lose one versus neon going to lose one, we can say that because helium is smaller, the nucleus has a stronger attraction on its electrons, wherefore we need more ionization energy to ionize. So then our second ionization energy will be greatest for lithium, next will be sodium, and then finally beryllium. Let's do another example. Third ionization energy. And we're going to have Mg, Ca, Al. They're going to lose electrons 3 times. Magnesium is going to lose 1 to give you the configuration of sodium. Same thing as Mg+, but I'm just writing it sodium here so you understand. But don't do that on an exam. This bottom part is what you think about, but this part is what you actually write out on an exam, okay? So sodium, and then this will be the first ionization, second ionization, and then it will lose an electron 1 more time. Okay. So let's see, third ionization energy. That means ionizing to get to the third. Ionizing to get to losing the third electron. So it's this part, this last part which I've circled. Neon to fluorine. Noble gas, losing electron. Very difficult. High IE. Argon to chlorine. Same thing, high IE. Sodium to neon. So alkaline to noble gas, very easy, low IE. Now, what's a tiebreaker here? Neon or argon? Which one's easier? Which one has higher or lower, whatever. So neon has a smaller size, That means the nucleus is closer to the electrons, increasing nuclear attraction. Increasing nuclear attraction means increasing Z effective. And increasing Z effective means you need more energy to ionize. So the smaller atom here will have the highest ionization energy, which in our final result, we're going to say the third ionization energy is greatest for magnesium and least for aluminum, and calcium stands in the middle. Now, we know that the trend for ionization energy is such that top right has the highest ionization energy. And we see that in this case, neon, argon, and sodium, such that it also follows the ionization energy pattern, where neon is the toppest right, so this one has the highest ionization energy. Whereas if you did not use this kind of analogy to figure out your configurations, you would just be looking at magnesium, calcium, and aluminum. Where's aluminum? And aluminum. And if you were talking about the first ionization energy, yeah, aluminum would have the highest first ionization energy and calcium the least because of top right, highest ionization energy. But because by the second ionization state, they are no longer the aluminum configuration, nor the magnesium, nor the calcium configuration, but they become the neon and the argon configuration. So that is what you base off your ionization energy off of. So in the end, it still follows a trend, but you have to look at which configuration they adopt, and that is the element you use to refer based off the trend.